Swayam Prabha. Digital India. Educated India.
So, before we begin, you have already been introduced to different specializations, different areas of civil engineering. You have already been, you know that. So, what I would like you to do first is take out your notebook and write down in the next 30 seconds whatever you think is a structure is. So, what is a structure? Before we get into structural engineering, just write down. It does not matter, you may not have even thought about it, but it is important to put down the first thought on the first day, and all I will assure you is that over your next 4 years stay here at IIT Madras, you will slowly improve upon that first definition, and by the hopefully by the time you graduate, you will know what a structure is, and particularly more importantly what a modern day structure is all about, and therefore what is expected of, if you choose to become a structural engineer at the end of your stay here, what is expected of you, right? So, please take 30 seconds, write down whatever you think a structure should be defined as. In this class, I will be using lot of photographs, beautiful photographs, so which are obviously not all taken by me, but I will take this opportunity to acknowledge all the contributors, individuals, organizations who have put up so beautiful images all over the internet, and some of my colleagues who shared for us to learn a subject. And so, for this academic purpose, I will be using them, and so I will acknowledge their contributions. If you have put down your thought on what a structure is, we will not get into that directly, but we will start with this idea of why do we build structures in the first place, right? And if I think of it, the first thing that comes to my mind is, one of these early cave paintings that we see. It's not just a painting, but it reflects the aspiration of human being as a race to do more, to do beautiful things. Just look at the vitality in these pictures, the creativity, the aspiration to do more that gets reflected in this. Human being as a race were confined in these natural caves and all, and that is where they wanted to go out and explore, right? And so it's not surprising that as a human race where we are, we have achieved whatever we have achieved. It's not surprising that urge was there long back, and to fulfill that urge, what human beings started doing is actually building structures. We will see that only helped them come out of those caves and build the world that we see today, right? So, it is a very fascinating journey that is facilitated by building things as we moved along our history. And so, the first thing was for movement and protection. But then there were, as we progressed as a race, there were other requirements also, and we started building for different purposes. Sometimes it just boiled down to, you create something so beautiful that it catches everybody's imagination and you just leave a mark, right? And that itself is a great achievement of human race. And we were able to do that by building, by constructing these beautiful structures, beautiful not only in terms of the architecture of it, but also in terms of the science behind it. And we will see why I say, or people say structural engineering is a combination of art and science. So, you just build one of these in your lifetime and you will be famous and known forever. The question is, are you willing to do that? So, if you really look at it, it's very simple. We have seen fallen logs, branches, and then we have used, not only we, but even other animals have used it as simple bridges, right? Taking inspiration from that, today we have managed to build massive, massive bridges. This particular bridge that you see, this length, any guess how much it can be? It's almost 2 kilometers long, and I want to keep this number in mind because it's important to understand the magnitude of it, the scale of it, right? It's more than 1.9 kilometers long. So taking clue from nature, we managed to do such massive things, wonderful things. And what was the whole purpose? The whole purpose is to come out and explore the world, to be able to move around, to move people, to move resources, right? So first, obviously, the option was to hunt, to get food, and slowly, move to newer places, looking for newer resources, which eventually led to conquering new lands for resources and for men, and then move on and move on, right? So movement or transportation of people and resources was important for us. I'm sure in your other classes on civil engineering, particularly hydraulics and engineering, you would have seen this or heard about this. This is transportation of water. Just look at this, centuries old structures still standing, beautiful. You just look at it and you feel good that yes, we as a race have done something beautiful in this world. That feeling is also important. So another example of beautiful Roman architecture and construction. And then in modern days, we took it one step forward, and so we make aqueducts, but now which can also support these ferries and all. It's not just a small one transporting water, but you actually transport people also, ferries or people also. So what it shows is that we are slowly expanding our domain. We are thinking bigger and bigger and bigger, and as we do that, we are capable of actually executing such dreams and making such dreams reality, right? That is important. Well, any idea what this is? This is what is called a ecoduct, where you have these animals, we are obviously transgressing into their land, and so they are getting threatened. So this bridge is not for humans, but for them to cross over safely across the highways that we have created for ourselves. This whole concept started in 60s, 70s in the Europe, and now it is very common in many parts of the world. So again, creating bridges. Talking of protection, obviously, the first thing that comes to our mind is we need protection from the nature, right? The natural hazards. And today, of course, we have natural as well as man-made hazards also. So what are natural hazards? Things like floods, cyclones, earthquakes, right? Droughts. So these are. And then today we have a lot of man-made hazards in terms of starting from pollution to even arson and so on and so forth. So if you really look at it, I'll just touch upon some of the very important ones, which are cyclonic occurrences. So you see that the whole of the coastline of India is actually prone to cyclones, and we have the eastern coast more prone than the western coast, and we'll see some data. So when we build structures, we have to ensure that whatever we build can take these natural events and protect ourselves. Flood is another natural hazard, and every year we see these reports of on one side we see drought, right, and on one side we see flood going on, and then earthquakes. So we have earthquakes occurring all over the India, and particularly the whole Himalayan belt, if you see, is very, very prone to earthquakes. So just to summarize this, if you visit the website of NDMA, what is NDMA? It is National Disaster Management Authority under Government of India. They list out a lot of natural and man-made hazards. Just to give you an idea, India as a country has about 60% of landmass prone to earthquakes of moderate to high intensity, has about 12% of land prone to floods and river erosion, and have about 76% of the coastline prone to cyclones and tsunamis. So what we see is we have to do more than natural and normal things as civil engineers, as structural engineers, to ensure safety of ourselves and the structures that we build in a country like India. And so we need good structural engineers. We need to understand all these things, effects, and then build structures accordingly. So going back, we started housing ourselves in caves which were natural, and then we started building caves. This is a very interesting example. It's a very soft sandstone. So they said that whoever could not afford a house would go and create a burrow in this ridge and then have a house for himself and his family, right? But then look at this. It's a very interesting example. Almost 2000-year-old a cave, a man-made cave. So we built such things for our protection from natural hazards, and this was hidden but then found recently, discovered very, very recently. So in terms of protection, in terms of building houses and all, of course we started with smaller things and then we aspired more and we built more. One of the very early fortresses or forts that you see back here in India, we have a beautiful fort, the Jaisalmer fort. Those who have visited will know. And we created these very, very massive structures, beautiful structures. But then that was not all. We aspired to do more, and there came a social and cultural, and you can add religious and so on and so forth issues to it, and we build structures like this. Not to talk about the great pyramids in Egypt, but also all over the world there are pyramids. But look at this picture. I like this picture for one simple reason. Look at the creativity. The creativity that we saw in that first cave painting is still evident here. If you see here, this is the face of a serpent, and on the March equinox, the sun falls in such a way that it creates a shadow. So starting from here, you see the serpent effect, and it happens on that particular day, right? So structural engineering is not just building something, but it's building something beautiful also. So if that was built with stones, this famous temple is built by cutting away stones. It's one of the largest rock cut temples in India, right? So of course it took a lot of time, lot of patience, but then if you do things calmly, peacefully, all it tells us is that we can do great things. One of the tallest temples in India, and when it was built, it was definitely one of the tallest in at least this part of the world. But the beauty is that they had put a 80-ton or so, one single stone at the top. How did they do that, right? And by the way, each of these structures that I'm trying to show has a history of its own, and you can actually spend your whole lifetime studying and understanding those. But that's not the point. The point is to see and understand and appreciate that as builders, as constructors, as engineers, people, without even having these phrases or these degrees associated with them, they did manage to build such beautiful things, massive things. So, if they could do, we can also do, is the belief with which we have to start. With all this came another dimension to our life, which is power. This is the view of Rome from, you guessed it, right? But again, to have authority, you have to look powerful, you have to look bigger, greater than the common. And one of the best ways of doing that was to build something so beautiful, so exotic for yourself, right? And that same thing went ahead in time. All of you know the story of this. Effectively, what it tells is that we wanted to come out of those caves, explore the world, and that urge, coupled with our inherent creativity and talent, made us do all this. So, we as a race is very important and we are capable. Only thing is, we now need to take that forward. So, if you really look at all these things, the early trends were we build structures which are massive, it's awe inspiring, right? But then slowly we started building long structures, tall structures, and today, of course, the buzzword is slim and fit, slender structures, right? So, just compare bridges. This is what we used to build earlier, and this is what we are building today. But it's not just a change of test, but actually there is engineering involved in this, and this is what we will be understanding over next your couple of days, or I would rather say over your stay here at IIT. Why is it that we are able to build these kind of structures that you see on the right today, which we did not build earlier? It is because of our understanding, because of materials, our understanding of how structures behave, our capability of analyzing structures and designing structures, and so on. And those are the items we will be discussing later. But just to give you a idea of how we have moved forward, let us take the example of tall structures. Just as an example, all of us know this structure, very famous. So, if you really look at it, it's just about 56 to about 60 meters tall, and in those days it was a marvel. I mean, even today it is, no doubt about it, right? And then in our own country we have this structure which is more than 70 meters tall, and then suddenly you see a quantum jump. Now, if you follow the construction, the material, you see that there is a sudden change now, right? It is possible, it was possible to build this because of something that happened in between, and we will discuss that later, right? So, suddenly we have moved up to this, and this whole thing gave that idea of, it's not just we want to create a structure where once in a while we can go up and then see, but actually we want to build buildings which will be tall, and so we want to live up there. So, very famous building, less than 300 meters tall, and in those days, just imagine, it was all built. I mean, you did not have, today you carry a smartphone which is a supercomputer, right? And we will see in structural engineering we will need physics, we will need mathematics, and so on and so forth. They managed to build this structure, and that actually created a race. So, everybody had to build a taller structure than the previous one, and so suddenly we got into this, we had this beautiful Empire State Building, and then we had these two, right? But still 400, about 400, still about 400, 450, 500. So, what we see is that it was simple to move to a certain level, and then it is becoming difficult and difficult and difficult to go up, right. But each one of these structural that buildings that we saw actually has beautiful but simple structural engineering concept behind it, and we will discuss those later. But we have reached here, and then of course, this is again a quantum jump. This is again a very, very quantum jump, but we are not satisfied. We are not satisfied. What is it that we are building? We realize that we have still not been able to bridge the 1 kilometer mark, right. We saw that bridge span nearly 2 kilometers. Now we are trying to go up, and we are struggling to go up 1 kilometer. So, the original idea was to have a 1 mile tall building, but then it came down to 1 kilometer, and that is what we are targeting. Of course, within this time frame, there are many more buildings, tall buildings, super skyscrapers have been built. Particularly China is going very, very aggressively in towards building these super tall buildings, and they have developed the capability, and so they are doing it. Others are also trying to do it. But so this is the forecast that by 2020 this is what we are trying to achieve, right. So the point is, imagine you are able to build a structure 1 kilometer tall. It's a massive, achievement as in terms of building. But having it tall is one part of it. As engineers, we would like to look at it in a slightly different way, right. So, we want to look at it in terms of a ratio, slenderness. So, what is it? Height to width ratio, or depth, or whatever you call it, length, right. So, if you look at this, what is that ratio? And if we have to draw a graph of all these tall buildings, that their height divided by their width, how does that graph look like? Okay. Take this up as a nice cute exercise and try to come up with this. So, as the number of stories increase, typically if you take these buildings as examples, you have got the heights, go and find the widths, the base dimensions, and see how does that vary. Is it a linear variation? Is it this variation, or is it this variation? What is it? Go and figure out. It's a very interesting thing. You will realize that, as in terms of structural engineering, we are reaching somewhere. And what is that? Talking of tall buildings, we also created massive structures in the form of dams, and I am sure you would have discussed this, different types of dams. One of the engineering landmarks is this Hoover Dam, built in 1930s in the US, right. It is a concrete dam, and remember, almost like what, 90 years back, the construction of concrete and of this scale was humongous, and so this is considered to be a landmark construction in this. Back here, well, look at this beautiful dam, Tungabhadra. Please do visit these dams. They are beautiful structures, and by the way, in modern India, dams are known as, yes, look at this, how beautifully. So, again, there are these hills, and within which this whole structure is built in such a way that it blends with the natural system that you have, right, and then you create this. Then of course, in terms of transportation, another important field of civil engineering, if you see, we had this golden quadrilateral, then we had this north-south corridor, we have the east-west corridor, and now of course, we are taking it one step forward and moving. And so, two things are happening. We need to create lot of bridges, and at the same time we realize that we have lot of old bridges. They are very old. So, we need to preserve them. So, we have work on two fronts: create new bridges, new structures, and preserve old structures. And for both of these tasks, we need very trained, qualified civil engineers, right? Just to give you an example, I mean, there are hundreds and thousands of this, but just to give you an example, how beautiful this bridge is. Going back, concrete, steel, a landmark bridge, and even modern day bridges. If you just look at it, this is the very recent bridge completed last year. Talking of bridges, actually, if you look at Indian Railways, it's breathtaking to look at the bridges that they have built. Not just road bridges, but we also have rail bridges, right? This is the famous Pamban bridge that you see here. The tallest pier that we will find in India is this. Just look at that height of that, those concrete piers, right? It's breathtaking. And this is part of the Konkan Railway project, and and you will find such beautiful structures there. We aspire to do more. That's the only thing that I can keep on repeating. So what we decided was, land is not enough. We created an entire airport in the middle of nowhere on sea, right? So beautiful project. There are a lot of information available. Do go and look at this. The whole airport is on the middle of a sea. And so you can imagine, we had structural engineers, geotechnical engineers, oceanographic engineers, hydraulic engineers, everybody working together, all civil engineers working together to create such a massive project, make it successful. One of the landmarks of 19th century civil engineering, the Panama and the Suez canals, right, connecting the Atlantic Ocean and with the Pacific Ocean, Panama, and then we had the Suez Canal thing. So all of these projects require a lot of multidisciplinary, in the sense that civil engineering in itself is a huge multidisciplinary area, right? You have geotechnical engineering, water resource engineering, hydraulics engineering, civil structural engineering, transportation engineering, all of them come together to create things like this, which serves. Once again, look at the size. This is a cooling tower. Just look at the sheer size of it. We have built such things. Today, for clean energy, we are going to build a lot of nuclear structures, power plants. So we are going to build a lot of these structures. Energy sufficiency is an important thing today. And what you see here is a very, very interesting project. This is what is called the Trans-Alaska Pipeline project to transport oil, fuel. And for this, engineers had to do a very unique innovation. So here is a pipeline, and if you see the pipeline, it's all bent, crooked and all. You must be wondering, why is it like that, right? And here, if you see, it is supported on something which is sitting on some rails. This is because it is crossing an active seismic fault, and so the earth moves when there is earthquake. And if you create one stiff pipeline across it, that pipeline will break. Okay? So you create these segmented pipelines with flexible joints supported on rails like this, so that no matter how the earth moves, shakes, the pipeline stays intact. So it's innovation. Or if you go to and you want to take a ride, you need a structural engineer to build that. Trust me. So every time you go and enjoy, thank a structural engineer to have designed it for you. Or you just go and build something which is so refreshing, breathtakingly beautiful, that you go sit there peacefully and enjoy a cultural evening. Well, we have our own also. So please do visit and see and stand there. And now that you are a civil engineering student, don't just go and visit these structures, but go there and take pride in the fact that yes, we have built it, right? You as a civil engineer should start taking pride in all this. But that is not all. You will find structural engineering basically, to put it in a very short way, anything that you build is built based on some science and some mathematics and some physics behind it, and the discipline of engineering which looks at all of this and make something stand or float is basically engineering. So we have structures which are on water, on land, on air, and we generally as civil engineers talk of those structures which are on land, and then we have the ocean engineering structures, and then we have these, and then we have systems which are in between, where also the principles of structural engineering, hydraulics engineering, geotechnical engineering, all of it is required to make things work, right? Just look at this. It has to withstand strong wind, it has to withstand ocean current, it has to support people working there, and so on and so forth, and do its function. Well, we have our version also to take tremendous pride in. This is the launch of Chandrayaan 2, by the way. So if you see this, you have this huge amount of structures, supporting structures, right? First of all, they have to stand to make the rocket stand, and then as it goes, you cannot let these structures fall apart and injure people. So they have to be designed, they have to be produced, built in such a way that it performs the intended purpose. And even here, you will be able to use the principles of structural engineering, mechanics, and so on and so forth that you will be studying over your stay here, to understand how these behave. But back on earth, I said this word, built environment. Whatever you see here works on these three pillars. So you have engineering, of course you have to have good governance, and so on and so forth, and then you have a social humanities related thing. But if you look at engineering as such, it all started with civil engineering in some form or other, right? If you go and look at all the old universities around the world, you will see civil engineering was there right from their beginning. In fact, civil engineering was there right from the beginning of mankind, as I said, and tried to impress upon it. Then of course mining was another important discipline of engineering which helped human race to progress. Metallurgy, mechanical, chemical, electronics, electrical, ocean, aerospace, and today we are at a stage where we can specialize and super specialize on small areas. But civil engineering still remains one of those very, very broad, discipline of engineering, where as a civil engineer, you will be learning, you will be discussing so many variety of things, like starting with geology. Why is it important? You cannot build anything on earth which is standing on earth without knowing what is below, right? Without a geotechnical engineer friend, you cannot build a structure. You have to know that. Right? So, and before that, you start with hydrology. You want to understand hazards. What are the things, loads that are going to act? Materials and construction techniques. I'm sure you have heard about it. Survey and remote sensing. When you saw that beautiful curve, how do you plan it? What is the best way to plan that bridge, right? Or the railway track that goes around. So very, very important. Hydraulic, water resource engineering, environmental engineering, transport. And so structural engineering is one of those parts of civil engineering, but civil engineering as a discipline of engineering is everywhere, is very much required for our own existence. So talking of structural engineering, one of the earliest things that was said is that a structure, I asked you to write down what you think a structure is right at the beginning, and it has to get improved over time. But what they say is, you must build something, a structure must be something that is safe, very important, useful, and beautiful. So if you now think back of all the photographs and structures that you have seen, first of all, they had to be safe. That means they are thousands of years old, they are still standing. They have not fallen on somebody, right? and they served a purpose, whatever that purpose is, whether it is for movement, for protection, for social reasons, for political reason, doesn't matter, it served its purpose. And most important of all, I mean, in a way, they're all beautiful. But today, safety, functionality, aesthetics are important, but we are dealing with a situation where we have to explicitly talk about durability. What we see is that those structures which are thousands of years old are still standing, but some of our recent structures are not really continuing to stand. So there must be some reason, something that on our way, on our journey, we are probably beginning to not do right. And so we need to understand that and then pay attention to this aspect also. And most important thing that is happening today is that today none of us are pharaohs or emperors and having unlimited land, unlimited resources and all. So economy is an important aspect of modern day civil engineering. You have to build structures within a constrained budget, and more importantly within a constrained timeline. You can't take 1 century to build a structure, although there are structures which are even going like that. So durability and economy are also going to be important facets, tenets of structural engineering, that as a student of structural engineering or civil engineering, you will have to understand and appreciate and then act accordingly. But safety is of paramount importance. If the structure is not safe, it's going to collapse, it's going to fall down, it's going to kill people. Not acceptable, right? And this is where your science, your physics, your mathematics all comes into picture, right? We need to understand how forces act on the structure and how a set of force is said to be in equilibrium for a structure to be safe. We need to understand compatibility of deformations, and we need to understand how materials behave, how members behave, how structures behave. So these are the scientific part of structural engineering that you will be learning as you move along. Only then you will be able to ensure that you have built a structure which is not only beautiful, not only useful, but safe. If we don't, things can be bad, and we will see things of which we will not be very proud. I hope you understand the end part of the picture, right? A whole expressway has fallen, of course due to earthquakes. But I said anyway, our job is to build structures to protect them and us against those natural hazards, right? So we have to do that, we have to learn. But then, as they say, it's okay, we should learn from our mistake. And that is another very, very important aspect of engineering. We have never done it right the first time, but we have learned from it and then moved forward, and that is why we have been able to progress, we have been able to do what we have done. So the important thing is to let go of your ego and say, okay, we have done something wrong and we will do it right the next time around. This is where comes an important part, which is, as structural engineer, you will have to feel, you have to understand how structures behave. And this is almost like psychiatry, that you understand how a person is behaving. You go inside the mind of a structure and understand how it's going to. Now, this may sound very weird to you today, that's absolutely fine. That's absolutely fine. But this is precisely what a good structural engineer will do. He will look at a structure and understand what is happening in the structure. Just like a good doctor will look at the patient and say, okay, I understand, I know what you're going through, right? Diagnosis, same thing a good structural engineer will do. And the whole training is about to train you to see a structure and understand how it is behaving, what is going on within the structure. And that's why you are here for the next few years, right? And that's the whole thing. And so to be able to understand how structures behave, we will understand how materials behave. We saw different materials, we will see how each one of them behaves. We will understand structural systems. You saw different systems without I explicitly telling or pointing out. You saw different structural systems, which we will discuss again next time around. And then we will learn, we will have to learn two very important traits, which is to be able to analyze a structure and to be able to design a structure. And what are these? We will also see next time around. But for all of that to be done, or for you to be able to do, you need to start off with a very creative mind. Trust me, it's not okay, some question is given, you do that. Civil engineering is very creative, as you have already seen. So you need to keep that alive in you, but at the same time you need to have a very, very scientific mind. You need to be, I know all of you are good, you loved your physics, you loved your mathematics, you loved your chemistry. Continue to love physics, chemistry, mathematics, all that, and you will be a good engineer. But you need to continue to love them. Okay, so first year, all the courses that you are doing, you need to continue to love them. But the important thing is to be motivated and to be disciplined, right? All forms of engineering. I am not talking about structural engineering here. It's important that you continue to be motivated, and motivation, the first motivation has to come from within. If you find it lacking there, come across, there are enough people in this institute who will help you. But you have to come across and say, we need motivation, we will get motivation. But you have to be disciplined. That is something that you have to work on. Nobody else can do that. And if you are able to manage all that, you need to dream first, right? And then make that dream happen. And that is what engineering is all about. And you have to first create a plan and then find ways to execute that plan. And I show this picture because I also taught engineering drawing, and I don't know if you as a batch is doing engineering drawing or not. Take that very, very seriously. Okay, take it very, very seriously, because that is where your creativity starts. And then if you get that right, you will be able to do many beautiful things. Okay.